Hello guys, welcome back to Techdose, and in this video we will understand about resiliency. That is, we will be understanding what are resilient systems, and this is from basics of system design. Let's see an example in order to get some better understanding. In this case, we are assuming that there is a user and this user can place an order. So actually this is an online food delivery app where the user has already added some items into their basket. Let's say milk plus bread. Okay, now since these two items have been added, now the user wants to check out, that is make the final order by paying. So the user clicked on the checkout, and so it went to the application server and it then routed to the place order service. The place order service will do a final confirmation by checking with the inventory that when you had added, maybe at the time of placing the order, some of these items may have been out of stock, right? So this check inventory service will actually check its inventory and say that yes, all the items are available, or what all items are not available, it will notify. And only after the user confirms that these are the items available and I want to place an order, so he can proceed with the payment system, that is he can pay and make the final order. Now in this case this works fine, but let's assume that this checking of the inventory system has gone down. Now in this scenario, what can happen? When the application cannot check with the check inventory service, then the application can never be sure about the availability. One way to get around this problem is to just place the order, just charge for whatever items are present in the basket, and then refund the money if later when the check inventory service comes up and we come to know that okay, some items were not available, so just do the refund. This will work fine, but then think about the user. Let's say the user ordered milk plus bread. So he is thinking about having the breakfast milk plus bread. Now if the bread was in stock but milk was not in stock and he just got the bread, now he cannot have the breakfast, right? So this will be extremely annoying for the user, and actually the user will lose confidence in this application and he may go ahead and explore some other application, right? Who do not make false promises. So we should always avoid making false promises. So false promises is the problem of this application with this approach. Another way to get around this problem is to wait and keep the order in pending. You can wait until this service comes up, and once this service comes up, then check and confirm and then place the order, right? But in this case your availability will be low, so you will be losing on business. Either way, either you lose your credibility and hence later on you will lose your business, or now you gracefully fail, or you wait and the availability gets hit and again you lose on the business, right? So this is happening actually due to the downtime of the check inventory service. If you compare one case, let's assume the case on the left side where the service actually went down at 1 p.m. and the service came up at 1:05, that is 5 minutes after 1. So the total downtime of the service was 5 minutes. On the other hand, if you compare another system, let's say this is system S1 and this is system S2. The similar type of service went down at 2 p.m. and came up again live 8 minutes after 2 p.m. Okay, so the total downtime was 8 minutes. Now, if you compare these two systems and if I have to ask you which gives a better service, then you will say that the one having the lower downtime will have a better service, right? So this only happens if we compare one system with another, but if we don't compare it, then you do not know if 5 minutes is good or bad. Now resiliency says that it is the capability of a system to come back to its operational state once it faces failure. You can say that 5 minutes is a kind of a measure of resiliency, and if you can come up within 3 minutes, then those kind of systems will be said to be more resilient, and if it comes up within 8 minutes, then it is less resilient, right? So it is kind of a comparative term. Now, how to measure resiliency? The last thing we saw was measuring in terms of time, which was mean time to recover. This was nothing but the difference between the end and the start time. That means how much time your service was actually unavailable. You take the mean of all those unavailable time, and then that will be the mean time to recover. Another way is to find out the RTO, that is recovery time objective, which is maximum time to restore a critical service after disruption. maybe you have 100 services in your application, but maybe 10% of those services are actually critical. A critical service is actually very valuable for running your application and directly impacts all your business. So let's say you have an animation service running which is used to decorate your website, and another one can be a payment system service. So payment service, you know that if the animation is not running for the time being, still users can actually place order and make payment. But if the payment service is not working, then that is a big deal, right? Even if the entire website works fine, but nobody can purchase anything. So that directly impacts a business. And if I have to compare between these two services, then I will say that the payment service is much more critical and very critical to any business, isn't it? So this is like the maximum time to restore a critical service. So it doesn't talk about the non-critical service, because your measurement may just include the critical service. If that is the case, use RTO. Another one is RPO, which is recovery point objective, which is the difference between the current and desired level of resiliency for a given service. So if we pick a service like payment service and we think about how resilient it is, like let's say I was expecting that within 5 minutes the recovery must happen after a failure, but it is recovering within 2 minutes only. So I will say it is performing better than expectation, isn't it? So this is kind of again a comparative term. Again, you can study resilience ratio of the actual and the potential impact of a disruption. So potentially, if your payment system is down, you can look at how much was your QPS, that is queries per second. If it was, let's say 100 and it was down for 1 minute, then you can just multiply 60 with 100 to get 6000 as the number of payments I request which was actually not served. So this is the expectation. But then let's assume that even though you were down for 1 minute, you got less queries for payment, let's say only 60, and hence 3.6k requests were not served. So in this case, the impact was less as compared to what the potential impact could have been, right? So this is also one of the way to study like how resilient is your system, and there are other terms as well. You can just go through it. Now if you picture about resilience, now it is kind of a comparative term where two systems are compared and then you get an idea of which one is more resilient. So you can mark it on a scale like a very resilient system to some system having poor resiliency. So again, if I have to define resilience in simple terms, then it is just the time difference between when your service is down and how much time it takes to make it again operational. So the capability of a system coming back to its operational mode again is resiliency. And if your system can do it with by taking less time, then it will be a highly resilient system. Otherwise it will have poor resiliency. I would like to announce about our live training programs, data structures and algorithms, which is interview dose, and system design, which is design dose. If you are looking for making a switch from service to product based, or even make a product based to product based top tier switch and aiming for your dream company, this is the best curriculum you can ever join. I'll be your mentor throughout the cohort and I will help you clear all your doubts in the one-on-one sessions. You can know more about this by querying us on the WhatsApp number, or you can also visit our website techdose.co.in. I hope this video was helpful. Please like this video and subscribe to our channel for more system design content. See you guys in the next video. Thank you.